This is part 4 of topic 4, imperfect competition, and once again we're looking at game theory, and we're going to be looking at some more complex games here. In the first game we're looking at Prisoner's Dilemma again, but we're looking at an infinitely repeated version of Prisoner's Dilemma. So I've set this up so that we've got two companies, Pepsi and Coke, rather than two prisoners, but it is Prisoner's Dilemma because of the payoff structure. So if you have a look at the payoff structure, it's the same as Prisoner's Dilemma in the sense that Pepsi has a dominant strategy of low prices, because low is dominant strategy because it will earn 17 and 8 rather than 12 and 6, and Coke has a dominant strategy of low as well. Low is, in this context, a cheat strategy. Same as Prisoner's Dilemma, they have an incentive to not get into a price war and cheat with each other, because that will earn profits of 8. They have an incentive to just play high and collude, and they will be charged 12. Okay, so we know that if this game is played once, they will both follow their dominant strategies, and they will end up with 8,000, 8,000. But what if it is infinitely repeated? So the game is played over and over and over again. Period 1, they may, if they've just, they're quite uneducated about this scenario, let's assume that they just followed their dominant strategies in period 1, which is the first time the game's played, and they earn 8 and 8. And in period 2, they might stay at 8 and 8, in period 3 as well. But quickly they're going to learn that by setting low prices, they're just, they're not earning as much profit as they could. So eventually through this realization, they're likely to go up to high prices and almost implicitly agree that they will just charge high prices. Let's not worry about renegade discounting like we dealt with previously. So there's no renegade discounting, there's just these pure strategies of either high or low. So they're going to end up quite quickly here at high. Even though the game may proceed in periods 4, 5, 6 and 7 at high, there is always an incentive for one of these companies to try to cheat and set some low prices for a period of time, with either the hope that the other company won't find out, or in the hope that the other company won't penalise them in any other way. So there's always an incentive to charge low prices and then maybe come back if you're not penalised or you're not found out. So maybe just charge these low prices to the market for a short period of time. Now, the problem that Pepsi faces is that Coke does have this incentive to cheat, to go from 12 to 17. And in fact, Pepsi's got the same incentive. But let's just assume that Pepsi has slightly higher morals than Coke, and that Pepsi wants to, even though it's breaking the law by actually colluding and setting these high prices, if it is actually an explicit collusive agreement, then that is breaking the law. If it's an implied one, it's a bit harder to prove. But let's assume that Pepsi's got higher morals and it doesn't cheat as willingly as Coke. So Pepsi needs to try to come up with two strategies that prevents Coke from cheating and from grabbing these profits of 17,000. Because if that happens, Pepsi's profit is halved from 12 to 6. Now, one profit is called the Grim Trigger strategy. And what happens is Pepsi lets it be known to Coke that if Coke cheats and sets low prices, Pepsi will respond by setting low prices as well, and will never agree again to actually collude and set high prices. So Pepsi says to Coke, if you cheat, I'm going to cut my prices as well down to a low level, and they will be low forever. So the game will then, from that point on, be played down the bottom right hand quadrant. So that is one possibility. It's a grim trigger strategy. It's a threat by Pepsi from Coke. The question, however, is that threat, is that strategy believable? If I was Coke, I wouldn't believe that, because by actually threatening to take me down here to the bottom right-hand quadrant, Pepsi is actually sacrificing $4,000 per period by following this strategy rather than agreeing to set high prices again with me. So it's just not believable that Pepsi would do this to its shareholders. So another strategy, and a more believable one, is something called the trembling hand trigger strategy. And that goes like this. Pepsi says to Coke, if you cheat on me, then sure, you will increase your profits from 12 to 17. So you'll earn $5,000 more in the next period. However, I will actually take you down to the bottom right-hand quadrant and be in a price war with you for as long as it takes for those profits that you made by temporarily cheating to be wiped out by being down in this bottom quadrant for several periods. So if you make, the threat could be if you make an extra $5,000, this is Pepsi talking to Coke, if you make an extra $5,000 by charging low prices, I will take you down to the bottom right-hand quadrant for 3 periods, and that will be more than enough to wipe out the short-term profit of 17 that you made, so that you will be better off just staying at 12 and 12, that is profits of 12,000 by maintaining high prices. Now that is a more believable strategy, because even though Pepsi, by taking the game down to the bottom right-hand quadrant after Coke cheats and sets low prices, Pepsi is making a short-term loss by following this strategy. But it's actually teaching Coke a lesson, and in the long term, it's probably a strategy which is going to maximize Pepsi's profit. So you are sacrificing short-term profits by getting into a price war with the aim of maximizing long-term profits by preventing Coke from cheating again. Okay, the next game is a finite version of Prisoner's Dilemma. Now, this is really an example of, it's hard to imagine an actual example of this in the real world, but it could occur, but we're going to treat it as just another interesting example of what game theory can do and what it can be used for, and how it can open your eyes to the type of strategic thinking that needs to take place between two companies in a duopoly or an oligopoly. So with this game, it is played 5 times. Now, Coke's optimal strategy is on the right-hand side again. Once again, Pepsi's got morals, Coke hasn't, and, well, let's just say that Pepsi has slightly higher morals than Coke, and Coke's strategy is on the right-hand side. So Coke's strategy for the 5 periods is as follows. High prices earn 12,000 in round 1. In round 2, high prices earn 12. Round 3, high prices earn 12. But then in the last round, set low prices with the expectation that Pepsi will continue to set high prices, because high prices have been set all along, and grab 15,000. So Coke cheats in the last period. Now, if Pepsi's smart, and Pepsi knows the payoff matrix, and it has worked through its strategies as well, then Pepsi will realize that Coke has this incentive to cheat in the last period. Why? Because it can't be punished, because there is no 6th period. So Pepsi, knowing that Coke has an incentive to cheat in the last period, will actually set low prices as well, because Pepsi wants to avoid earning this 6,000. So Pepsi's convinced itself that in the last period, Coke will set low prices. Pepsi does what is best for it and charges low prices in the last period as well, to avoid earning 6 and to actually earn 8. So in the last period, the game will end up in the bottom right-hand quadrant. But then Pepsi thinks to itself, well, Coke's going to realize I'm going to do this, because Coke's not dumb. So in the 4th round, Coke is likely to bring forward its cheating strategy to the 4th round to try to get ahead of me there. So what I'm going to do in the fourth round is cheat to avoid the $6,000 profit when Coke cheats. I'm going to cheat as well. So then in the third round, Coke is going to realise that Pepsi's likely to do this, and Coke will then cheat in the third round to try to grab this profit of $15,000. But Pepsi's going to realise that this is likely to happen, so Pepsi will cheat and set low prices in the third round as well. The whole thing unravels. And so even though the optimal strategy was to go high, 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 low, what will actually happening, and if the game unravels like this, which is a reasonable assumption that it will unravel, is low, 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 low. Okay, so that's one problem associated with finite prisoner's dilemma. Because it's not an infinitely played game, the ability to actually threaten and punish the opposition is weakened, and there's a greater chance that it will actually unravel. Okay, so these are payoff matrices that we've been dealing with. The next game is a sequential coordination game. So with this setup, we use this sort of payoff matrix when both companies have to, or both players of the game, have to choose what they are going to do, choose their strategies simultaneously. If the game needs to proceed so that one person makes a decision and then the other person responds, then it's a sequential game. So this game here, we've got M, a manufacturer, and R, a retailer. The manufacturer makes a product that the retailer sells. Now, the manufacturer's first decision is to either update the product or not update the product. What I mean by that is perhaps put out a new version of the product. The retailer then has two strategies. It can either continue supporting the product or discontinue supporting the product. Supporting the product, continuing to support the product, means that the retailer has the product at the front of the shop on display and really promotes the product. Discontinuing support means that the product is just on the shelves with all other products. The manufacturer then makes the next decision. So these decisions are sequential. First of all, the manufacturer decides to update or not. Then the retailer decides whether to continue or discontinue support, and then after that decision is made, the manufacturer will decide to either advertise the product or not advertise the product on national media, which will then benefit the retailer through increased sales, as well as increasing sales obviously for the manufacturer. It will benefit the manufacturer as well. So when you've got a complex game like this, trying to think through the sequential moves and trying to find a solution to the game is far more challenging. So to actually do it, what we need to do is develop two sub-games. The first sub-game starts from decision 1 for the retailer, R1, and so it involves this part of the tree from R1 onwards. The second part of the game starts from R2 and involves the lower part of the tree. So let's analyse the upper part of this tree and start from R1. Now R1 wants to make maximum profit, and we've got the payoffs here in brackets, and the retailer's profits are first, the manufacturer's profits are second. So the retailer is at R1 and it's got to think to itself, well, do I continue or discontinue? And the retailer thinks to itself, well, if I continue, what's the manufacturer going to do? The manufacturer is actually not going to advertise, grab the profit of $350. So if I continue, the manufacturer will not advertise, and as the retailer, I will earn 100. Then the retailer says to itself, what happens if I discontinue? Well, if I discontinue, the manufacturer is going to want to advertise and grab this profit of 280. in which case I earn 120. So the retailer says to itself, if I continue advertising, I'll earn 100. If I discontinue advertising, I'll earn 120. So the retailer knows that if the game gets to this upper level, the retailer will earn 100, will take the 120 over the 100, and therefore the manufacturer will earn 280. So if the game gets moved up here to the upper tree, the game will end up there with payoffs of 120 and 280. Then the retailer says, well, if I'm down here, this part of the game, what's going to happen? Well, if I continue, if there's no update, there's obviously no advertising of the new product, the new version of the product. So if we play this part, the retailer says to itself, if I continue supporting the product, I'll earn 60. If I discontinue, I'll earn 130. So obviously if the game is pushed down here to R2, the retailer is going to discontinue to earn 130 rather than 60, in which case the manufacturer will earn 150. So we've just worked out if the game gets pushed to R1, the payoffs will be 120 and 280. If the game gets pushed down to R2, the payoffs will be 130 and 150. So literally it is 120, 280 versus 130, 150. But it's the manufacturer who has the first decision. So the manufacturer is obviously going to prefer this outcome of 120, 280 rather than 130, 150. So the manufacturer is going to update the product knowing that the retailer will discontinue support, knowing that it will then advertise and earn 280. You have to acknowledge here that the payoffs to the manufacturer of 300, 350 and 380 are not available to them. The manufacturer can never earn those profits. 280 is the best the manufacturer can do. So update, discontinue, advertise, 120, 280, that is the solution to the game. In this next game, we have a potential entrant and an incumbent. And what's happening here is that the potential entrant has developed a new product, or is thinking about developing a new product. No, has developed a new product. The incumbent is selling a similar product. Now, the potential entrant goes first. The potential entrant has two options: to enter the market and start selling their new product, or to stay out of the market and give the incumbent a license to sell their new product on their behalf. Now, if the potential entrant enters the market, then it knows that the incumbent, whose profits are listed first, the incumbent will actually set a low price, and therefore the potential entrant will earn profits of 40. So if the potential entrant enters, I've got a dot there next to where the game will end up. It will end up at A. If the potential entrant stays out, however, it knows that the incumbent will actually grab this $80 of profit by charging a high price, and so the game will end up at B. So what's the potential entrant going to do? Well, the potential entrant knows that it has a choice of either earning $40 or 30. So the potential entrant will enter, knowing that the incumbent will charge a low price, and it will earn $40. Once again, there are better payoffs to the potential entrant on this game tree, but those better payoffs are just not available to that incumbent, because not available to that potential entrant, because the potential entrant is in a competitive situation here, in a competitive market. The potential entrant cannot just select the highest payoff for itself, because someone else has a say in that, in what happens in the market as well. Okay, so that's the way that game would be played. So what I've got now is the same game, but I'm changing the order in which the game is played. Previously, the potential entrant made the first decision, and the incumbent made the second decision. And so the incumbent actually ended up with a profit of 50. The question is, can the incumbent do anything to change the game so that it gets a better outcome? Can the incumbent change the game to get a better outcome? And it actually can by making the first move. And so what the incumbent does is it actually commits to a price prior to the potential entrant actually entering the market or staying out. So the scenario is the incumbent has found out that the potential entrant has got this new product. The potential entrant and the incumbent knows that this potential entrant needs to either make a decision as whether to actually enter the market or stay out of the market and let the incumbent in the marketplace license the product. Now, by changing the order of the game, the incumbent knows that the potential entrant is making this decision of whether to enter or stay out. It hasn't made the decision yet, it's making the decision. So to try to get a first mover advantage, the incumbent commits to a price signal. The incumbent selects either a high, moderate or low price, just as it did in the previous game, but it does it so that that price selection of either high, moderate or low price is a first move. So for example, it would, before the potential entrant makes its decision to either enter or stay out of the market, the incumbent comes along and goes on a national advertising campaign committing to one of these prices, either high, moderate, low. And so throughout the country, it commits to one of these three prices and tells consumers what this price is going to be and commits to that price for the next 2 years and promises all consumers that that will be the price. The question then is, what price should it commit to? A high price, moderate price or low price? Okay, well, we know that the incumbent now commits to the price as the first move. So if it commits to a high price, the incumbent knows that the potential entrant will actually enter the market and earn 80, in which case the incumbent only gets 0. So it's not a very attractive option. If the incumbent pre-commits to a moderate price, then it knows that the potential entrant will grab this $60 by staying out, in which case it earns 70. And the incumbent knows that if it pre-commits to a low price for a period of, say, 2 years, the potential entrant will take $40 rather than 20, and the potential entrant will enter the market rather than staying out, in which case the incumbent earns 50. So the incumbent knows that by actually moving first, it can earn either 0, 70, or 50. So the incumbent is going to commit to a moderate price signal, knowing that that will earn it $70. And that $70 is actually better than the $50 that it earned by allowing the potential entrant to be the first mover. Now, an obvious question here is, how do we know what all of the strategies are going to be? How do we know what the outcomes or the payoffs are going to be? Well, in the real world, you don't. You have to try to guess what the different strategies that you and your opposition will play, try to guess what they are, and you have to make a best guess at what the payoffs are going to be. So trying to come up with these numbers is going to be very difficult, but if you can have a guess, then at least you've got some sort of insight into the different strategies that both you and your potential competitor are faced with, and hopefully you can make then a more informed decision rather than just simply not considering this type of analysis at all. So just to finalize this presentation, in this game, the incumbent went second. In this game, it went first. By becoming a first mover rather than second mover, it actually moved first, and it improved its profit from $50 up to $70.